Hello guys, let us start the second review, for the second exam, trigonometry. And the first question is, write the function value in terms of the cofunction of a complementary angle. So we want to express tangent of pi over 8 in terms of cofunction. The cofunction of a tangent is cotangent. And the complementary angle is the angle that adds up to 90 degrees, or in terms of radians, it will be pi over 2 minus pi over 8, right? So our angle and pi over 8 make together pi over 2. Okay, to subtract pi over 8, let us make the same denominators by multiplying by 4 over 4. Pi over 8 minus pi over 8 is 3 pi over 8. So tangent of pi over 8 equals to cotangent of 3 pi over 8. Find cosine of 4 pi. 4 pi is a quadrantal angle, so the terminal side coincides with one of the axes. So 1 pi is a straight angle, 2 pi coincide with positive x-axis. Here's 2 pi. Here is pi over 2, 3 pi over 2. So 4 pi will be 2 complete rotations. So on a unit circle, it will be the point with coordinates 1 and 0. 1 means cosine. If it is on a unit circle, then this is cosine. This is sine, the second coordinate. So cosine of 4 pi is 1. Find the exact value of s in the given interval that has the given circular function value. Okay, interval is from pi over 2 to pi, so we are in the second quadrant. Pi over 2, pi. So in the second quadrant, cosine is negative. Negative square root of 3 over 2. Negative square root of 3 over 2 is one of special angles, so the reference angle will be 30 degrees, so pi over 6. You can consider reference triangle to recall is it 30 or 60. Yes, so this time it's 30 degrees, so pi over 6. So cosine okay, so the reference angle is pi over 6 and or s prime. So our angle will be pi minus pi over 6 or 5 pi over 6. Suppose that point P is on a circle with radius 12 meters and rotate ray OP is rotating with angular speed 4 pi over 3 radians per minute. Angular speed is 4 pi over 3, radius is 12. And what is the distance traveled by P along the circle in 15 minutes? Time is 50. The distance traveled by a point by radius multiplied by the angle theta. Is generated with angular speed omega radians per minute in the time given by t, 50 minutes. So we just multiply the values, 12 times 4 pi over 3 times 50. It's 800 pi. Determine the amplitude, period, horizontal and vertical translation of the given function. So the first number 1, positive 1, describes the vertical translation. So when you start graphing, you first grab the sign, and then you move it according to this number that is added or subtracted. Since 1 is positive, the vertical translation is positive. So 1 unit up, positive vertical translation. This negative sign is responsible for reflection. It does mean that we move it down. This is reflection because it makes every value of sign to change sign, positive to negative or negative to positive. Okay, 5 is the amplitude. So vertical stretch. Original sign will be stretched so that it oscillates between 5 and -5. Then, argument of sign, x over 3 minus pi. X over 3 is bx. So coefficient b is responsible for change of period. This example, b equals 1/3, so the period will be 2 pi over b, or 2 pi divided by 1/3. You can multiply by 3 numerator and denominator and receive 6 pi. So the period is 6 pi. And now the last one, the horizontal shift. For horizontal shift, you must first factor out b. So horizontal shift must be subtracted from x, not from bx. Okay, so we have x over 3 minus pi. We must factor out 1/3. So x is alone without coefficient. Then the second term will be 3 pi. You can check it multiplying back by 1/3. It will be 1/3 minus pi. So since it is with minus, then horizontal shift is positive 3 pi. So if it were with plus here, then it would mean negative horizontal shift. Positive horizontal shift means the shift in the positive direction of x-axis to the right. Okay, next one. Graph the function y equals 3 sine x over 4. So first, a sine graph starts from the middle. So there is no vertical or horizontal shift here. So sine always starts from the middle and goes either up or down. If it's a positive sign, it goes up. If it's a negative sign, then it would go downward. But it always starts from the middle line. Okay, then we need to know the period of the sine. The period can be determined 2 pi divided by b. B is 1/4 here. 2 pi divided by 1/4, 8 pi. And it oscillates between 3 and -3, since amplitude is 3. Graph the function -1 minus sine x. So this time we have vertical shift. So we start with negative sine graph. Sine, it also starts from the middle, but first goes down, then up. Oscillates from -1 to 1. And then we must shift the graph 1 unit down. So every point of the graph goes 1 unit down. Graph the function -3 secant x. So to graph a secant, have the corresponding reciprocal function, -3 cosine x, and then add u forms to each maximum or minimum. If you have a multiple choice on the screen, so 5 different graphs, then for each graph like this, add the corresponding sine or cosine function and look which of them is your function. Okay, so if you graph a function from the beginning, so first graph the reciprocal one, it's -3 cosine. So it will oscillate between 3 and -3. Cosine usually starts from its maximum and goes down to the minimum and then up again. Negative cosine is just flipped over. So it starts from minimum, then goes up to its maximum. Okay, let me dotted line. Down, back to the minimum. And it repeats the behavior again and again since it's periodic function. Okay, the secant touch the cosine graph at every maximum or minimum. We'll have asymptotes at every 0 of the cosine graph. Okay, so if you see several graphs, just add sine or cosine and look which of them is your sine or cosine. Next one. Simple harmonic motion equation. We want to find s of pi over 9. So we just substitute pi over 9 into this equation. -6 times sine of 12 multiplied by pi over 9. We can divide numerator and denominator by 3. In the numerator and 3 in denominator, so -6 times sine of 4 pi over 3. Let us locate 4 pi over 3 on the unit circle. Here is pi, just 3 pi over 3, and the 4th pi over 3 will be in the 3rd quadrant. sine is negative square root of 3 over 2. The coordinates of this point on the unit circle, negative 1/2 and negative square root of 3 over 2. Negative 6 times negative square root of 3 over 2. Positive 3 square root of 3. Write the expression as a simple function of alpha. Here we have cosine of a sum. We can use the formula for cosine of a sum, cosine of the first times cosine of the second minus, since here's plus and the formula must be minus sine of the first times sine of the second. So 90 degrees, circle, the coordinates of this point are 0 and 1, so cosine is 0, sine is 1. So we have only the second term, negative alpha. Find the exact value of cosine of 165. We use the formula for cosine of a sum. We want to represent this angle as a sum of two angles that can be found in a unit circle, like 60, 30, 45, or in this example, we can take 120. Cosine of 120 plus 45. And then apply the formula for a sum. Cosine of the first plus times cosine of the second minus sine of the first, sine of the second. Cosine is negative 1/2 and sine is square root of 3 over 2. 5 degrees, both sine and cosine are square root of 2 over 2. Let us substitute. Negative 1/2 times square root of 2 over 2 minus square root of 3 over 2 times square root of 2 over 2. Both denominators are 4. So we write this as one fraction, negative square root of 2 minus, this can be square root of 3 times 2 under 1 root. So minus square root of 6, or like this, minus square root of 2 plus square root of 6 over 4. Choose the expression that completes the identity. Okay, so we can write all function in terms of sine and cosine, or here we can use reciprocal identity or quotient identity. So we can use that tangent is 1 over cotangent. So we can write cotangent x over 1 over cotangent x as cotangent squared x. Its expression will be equal to cotangent x times sine squared x. Cotangent is cosine squared over sine squared times sine squared. Sine squared in the numerator and in the denominator can be cancelled out, so equal to cosine squared x. For this question, you will need to show your work to write the formulas that you use to simplify it or to transform the expression. Tangent minus cosine times sine. Let us write tangent in terms of sine and cosine. Sine x over cosine x minus cosine x times sine x. Both terms have the same factor, sine x, that can be factored out. 1 over cosine minus cosine. Okay, what can we do here? We can write the two terms with the same denominator. So like multiply this cosine by cosine time over cosine. Don't change the value of the expression because cosine over cosine is 1. Then we have sine x multiplied by denominator. It will be the cosine x for both terms. The first numerator is 1, the second numerator minus cosine squared. On top, you see the part of Pythagorean identity. Squared plus cosine squared equals 1. If you subtract cosine from the left and from the right, you will get sine squared x equals 1 minus cosine squared x. Substitute this into numerator, and then you get sine x times sine squared x over cosine x. You can combine sine and cosine, sine over cosine, x times sine squared x. So this expression equivalent to the original expression. And the last one, given the values of sine and cosine, find cotangent. Cotangent from cosine theta over sine theta. Let's divide them. 1 over 3 divided by -2 square root of 2 over 3. So we can cancel the negative sign. Negative over negative is positive, and we can cancel denominators. Let us multiply by 3 numerator and denominator. And we have 1 divided by 2 square root of 2. So we want to remove square root from the denominator to rationalize it. Let us multiply by square root of 2 over square root of 2. Have square root of 2 in the numerator and 2 times 2, 4 in denominator. Okay. Thank you.